So today I'm going to present our paper entitled Evaluating the Performance and Challenges of Prompt-Free Short Text Classification, prepared by me, by Achraf and Francois Azelart. So text-based commands play a crucial role in providing feedback for various industries. However, effectively filtering and categorizing this feedback based on custom context-specific criteria requires sophisticated language modeling techniques. While traditional approaches have shown effectiveness, they often require a substantial amount of data to compensate for their modeling deficiencies. In this work, we focus on highlighting the performance and limitations of prompt-free short text classification using open source pre-trained sentence transformers. On one hand, our search includes a comparative study across different benchmark datasets, encompassing 9 dimensions such as sentiment analysis, topic modeling, grammatical acceptance, and emotion classification. Also, we worked at marking different experiences to test prompt-free few short classification. On the other hand, we underline prompt few for short classification limitations when the target criteria are complex. So here we are focusing on automated scoring systems which are capable of evaluating text-based classification on custom criteria, offer significant advantages in various domains. In fact, the ability to automatically access and score text provides efficiency, consistency, and scalability, enabling industries to process and analyze large volume of text data accurately and quickly. However, traditional objective-specific methods often face limitations in capturing language nuance and thus failing to adapt to abstract classifications concept without relatively huge amount of training data. These limitations have become gradually accessible since the exploration of general purpose, or limitations have become gradually accessible since the exploration of general purpose of foundation models. The term has been popularized by Stanford research team to highlight large models that learn general knowledge from an expensive or extensive quality and quantity of data and manage to perform well in downstream tasks without being specifically trained for them. Numerous companies require a precise scoring mechanism of their client feedback or their customer service resolution notes. However, a significant challenge arises due to varying classification objectives across different scenarios. In fact, allocating extensive resources in terms of budget and time for each specific use case becomes impractical. Consequently, leveraging foundation models that are accessible to the open source community offers a valuable solution. For example, if we efficiently fine-tuning smaller foundation models locally with limited training data proves to be effective. Additionally, the option of using a compact yet efficient language model should not be overlooked, particularly when generating representative training set poses a challenge. Overall, this work outlines a strategy to leverage these approaches, empowering companies to swiftly align with the latest advances in fields of minimal investment and effort, and also in time. Here, the studied approach by first fine-tuning the set using the contrastive learning with Siemens network. The ST learns context-specific sentence representation facilitated by training and the classifier head afterwards. So the input here is the few sheet for the training data, and the output is the classification head training. By obtaining a trained classification head, it passes by different phrases such as the fine-tuning and the classification. The first step, the generate sentence pairs. After that, fine-tuning, pre-prepared data. After that, we move to encode sentences with fine-tuned using the few-shot classification. The data used are well known as reference benchmarks for their specific use case. They are all available through Hugging Face Data Hub. Since we want to evaluate few-shot classification on these datasets, we need to make sure that we have enough observations in each call inside the training set to be able to study the model efficiency for different training set sizes. Moreover, observing an imbalance in test set labels can explain the future potential shift between accuracy, precision, and recall also. Firstly, we have enough samples in the training to evaluate few-shot classification models. However, IGNews and EMDB databases are perfectly balanced in contrast to COLA and emotion test datasets. So the accuracy measures can be based in the latter case. Overall, we have enough samples to compare several models' performance. If you want to take my paper, you will find an explanation of the used database and other details about this data. The first step here is to explore sentence transformers. So here in our benchmark study, we leverage advantage sentence transformers initially trained to excel and recognize semantic similarities between sentences. These sentences transformers are built open language models pre-trained on extensive text data, allowing them to capture intricate semantic relationships. A pivotal component is the pooling layer, which condenses information within the model's hidden states, producing meaningful sentence embedding. To identify the most promising sentence transformers, we initialized our selection process by considering open source benchmark available on Hugging Face. We also considered the model's parameters count ranging from as few 22 million to several billion. Our primary focus on conducting throughout comparison of the most promising sample and small language models, emphasizing their cost efficiency and energy consumption. Another crucial factor to consider is the model's licensing. Licenses that allows for potential commercial use are preferred as they empower the community and small businesses to compete with closed source models and those operating under proprietary licenses. So according to a survey conducted by the Natural Language Processing Foundation in 2022, approximately 70% of NLP practicing reporting using open source LLMs, large language models, while around 30% said that they utilized closed source models. Another way to look at the distribution of open AI closed source LLMs is throughout GitHub repositories. Here, to mention some results, to ensure a comprehensive evaluation, the fine-tuning process involved incrementally increasing the number of labeled examples per class, starting from 10 and gradually scaling up to 30, 50, and 70, and ultimately 200 examples per class, in addition to set fit to evaluate a traditional approach considering of training or logistic regression avec term frequency, inverse document frequency, TF-IDF, in a few-shot way. Another traditional method resides in training convolutional neural network with enough data. In our case, 1000 observation of each class value, while the statistical method serves a minimum performance reference achievable in a few-shot way with almost no cost. The CNN, or the convolutional neural network evaluation, offers a maximum reference performance that we hope to be able to surpass with as low as 10 shots instead of thousands. The evaluation metrics, including accuracy, precision, and recall, were rigorously measured at each fine-tuning stage, utilizing an independent test set previously introduced in the study. The precision and recall were aggregated and not weighted average across all classes. This methodological approach gives a global comparison of the open source models over different use cases, aiding in the identification of the most effective model for each task. This figure, the only issue in randomness introduced during training set to each state ideally, we would have repeated the training set for each number of examples per class several times and save the mean and standard deviation as robust indicators. This approach is used in a fixed number of examples per class for an advanced comparison later in the study. Here, to make a discussion in our stage, we employed relatively small language models and achieved a comparable performance level up of 80 and reached 90%. However, our approach does exhibit certain limitations, particularly when dealing with sentences that are ambiguous and fall between two distant classes. To address this challenge and optimize our methodology, we have identified two potential solutions. The first approach involves incorporating hard negative into the training set with the hope that these challenging examples will enable our smaller models to uncover most robust underlying criteria for classification, thereby enhancing their performance. Alternatively, we can opt for scalability by employing large models such as 1B, 3B to even large variants, and closely monitoring the impact of scaling on our classification tasks. These strategic considerations provide us with valuable avenues for further refining our approach and tackling the nuance of ambiguous sentence classification. When confronted with a complex classification criteria such as grammatical acceptance, prompt-free, future classification becomes very impacted by the training set choice, since the task has not semantic dimensionally, then creating small yet representative training set can prove to be extremely difficult without the help of a linguistic expert in making meticulous representative choices. So here, in this work, we investigated the efficiency and constraints of state-of-the-art prompt-free short classification approach using foundation models compared to conventional methods. The fine-tuning of sentence transforms model or the set fit demonstrated efficiency in addressing semantic criteria like sentiment analysis, emotion classification, and topic modeling. However, set fit faced challenges in accurately classifying intricate criteria such as grammatical acceptance or resolution note qualifications. The complexity lies in the development of a compact yet representative training dataset. Overall, our findings indicate that prompt-free short classification methods outperform prompt-based approaches when the classification criteria has a semantic dimension is not too complex. This advantage stems from the constructive fine-tuning, which offers sentence representations adequately embedding the separation characteristics in the future. We are excited for the future of both prompt-free and prompt-based future classification, as well as the several other downstream tasks. One of our perspectives is fine-tuning and instruction of the LLM or the large language model to optimize its downstream task performance, potentially using the other methods such as the GPEFT or Clora to reduce the GPU memory requirements for larger models training and inferences. So this is the next step that we will mention or that we will work in our research methods. Thank you all for your attention.